Welcome back to the virtual class of Milestone College. Dear students, today I am going to teach you chapter 2 of first paper, Qualitative Chemistry, and today's topic is solution. First, you have to know what is solution. And dear students, you can see three types of solutions are given in the whiteboard. Before learning solution, I would like to knock you about the homogeneous mixture. A homogeneous mixture is a mixture in which the composition is uniform throughout the mixture. Example, all those are actually homogeneous mixture. Here the mixture of sodium chloride, you know that sodium chloride is edible salt, and water. This is actually the aqueous solution of sodium chloride. Now come to the definition of solution. A homogeneous mixture of two or more components in which the particle size is smaller than 1 nanometer is called solution. Its composition can be changed in a definite range. Dear students, you can see there are two parts in a solution. Here one part is water and the another part is sodium chloride. Actually, the water is here solvent, and sodium chloride is solute. Now, what is the definition of solvent and solute? In the solution, the component which is larger in amount is called solvent, and the component that is dissolved in the solvent is called solute. Example, already I have given you the example. Water is solvent here and sodium chloride is solute here. Dear learners, you are watching three types of solutions here. For the better identification, I have used here three colors of marker. Here actually I have represented three types of solution. First one is unsaturated solution, saturated solution, and supersaturated solution. Now you have to understand that what is saturated solution. Firstly, I would like to clear about those examples. At 27 degree centigrade temperature, in 100 gram water, maximum 36 gram sodium chloride can be dissolved, and that's why this is the saturated solution. But in case of unsaturated solution, the amount of sodium chloride is less than the maximum amount. So what will be the definition of unsaturated solution? At definite temperature, a solution that contains less than the maximum amount of solute that is capable to being dissolved is called unsaturated solution. And saturated solution. At definite temperature, a saturated solution is a solution that contains the maximum amount of solute that is capable to being dissolved. Now you can see the example of saturated solution and supersaturated solution. In this case, the dissolved solute is actually more than the maximum capacity of solvent. Now come to the supersaturated solution. A supersaturated solution is a solution that contains more than the maximum amount of solute that is capable of being dissolved at a given temperature. Here, the maximum capacity of dissolving sodium chloride in 100 gram water is 36, but in case of supersaturated solution, I have given here 40 gram sodium chloride. It means 4 gram sodium chloride is given access. That's why this is supersaturated solution. Now, the dear students, I would like to discuss about the solubility. Solubility of a substance at definite temperature, the amount of solute which is required to prepare the saturated solution in 100 gram water is called solubility of that product. At this figure, we can see at 27 degree centigrade temperature, if I dissolve 36 gram sodium chloride in 100 gram water, then it will be the saturated solution of sodium chloride. I mean 36 gram sodium chloride is required to prepare the saturated solution in 100 gram water. So, I can say the solubility of sodium chloride is 36 gram per 100 gram water, and it can also be written as 36 just without any unit. So, solubility S is equal to M divided by M minus M into 100. Hence, solubility is equal to weight of solute in gram unit divided by weight of solvent in gram unit into 100. At 25 degree centigrade temperature, the solubility of potassium nitrate is 31.6. At 25 degree centigrade temperature, the solubility of potassium nitrate is 31.6. What does it mean? Actually, if 31.6 gram potassium nitrate is dissolved in 100 gram of water at 25 degree centigrade temperature, then it will be the saturated solution of potassium nitrate. That's why the solubility of potassium nitrate is 31.6 gram per 100 gram water at 25 degree centigrade temperature. Solubility is also calculated in mole per liter unit. In that case, it is known as molar solubility. Suppose at definite temperature 25 mole of solute is dissolved in 1 liter water. So, this is the molar solubility of this solute, and the solubility is 25 mole per liter. So, what will be the definition of molar solubility? At definite temperature, the number of mole of solute which is required to prepare saturated solution in each liter of solution is called molar solubility. Solubility is influenced by type of solute and type of solvent also. First one you can see at the whiteboard, type of solute. Here in both cases I have taken water, I mean same type of solvent, but the solutes are different and they are sodium hydroxide and calcium hydroxide. Dear students, you know that sodium hydroxide is more ionic because the cation contains only one charge, and the calcium hydroxide is less ionic than sodium hydroxide because the charge of cation is 2 here. So it is more ionic, I mean sodium hydroxide is more ionic, that's why sodium hydroxide is more soluble in water. All of you know that water is a polar solvent and calcium hydroxide is less ionic than sodium hydroxide. That's why the solubility of calcium hydroxide is less than sodium hydroxide in water. I mean if the ionic character is more, then it will dissolve in the polar solvent more. If the ionic character is less, it will less soluble in polar compound. And again, type of the solvent is also influenced the solubility. Here I have taken the same solute in both cases, and that is sodium hydroxide, but the solvent is different. In one case this is ethanol is less polar and water is more polar, and sodium hydroxide is ionic type substance. So here sodium hydroxide is less soluble in less polar compound and sodium hydroxide is more soluble in more polar compound. Actually ionic type substances is more soluble in polar type solvent. So I can say solubility of a solute is based on the type of solute and solvent also. Solubility of a substance is also influenced by temperature. Also influenced by temperature. Suppose sodium chloride, mixture of sodium chloride and water, this is a aqueous solution of sodium chloride. In this case heat is evolved, so this is an exothermic process. This is an exothermic process. So if I increase temperature, the solubility of sodium chloride is decreased, and after a certain period I will get the crystal of sodium chloride in the solution system. And if you consider sugar, mixture of sugar plus water, this is an endothermic process. If you increase the temperature, the solubility of sugar is increased, And now I would like to show you Glover salt. You know that the formula of Glover salt is sodium sulfate dot 10 molecules of water. The solubility of Glover salt is increased with the increasing of temperature, and it will increase up to 32 degrees centigrade temperature due to the presence of crystal water. But after removing this crystal water, the solubility of sodium sulfate is decreased with the increasing of temperature. So I can say the effect of heat on the solubility of Glover salt is two types. Initially, the solubility of Glover salt is increased with the increasing of temperature, but after 32 degrees centigrade temperature, the solubility of sodium sulfate is decreased with the increasing of temperature due to the absence of crystal water. Those 10 molecules of water are actually crystal water in the Glover salt. Effect of pressure on solubility. Actually, if the solute is solid or liquid and the solvent is liquid, in that case there is no effect of pressure on the solubility of that solute. But if the solute is gas, in that case there is a effect of pressure on the solubility of that solute gas. Suppose if I consider the soft drinks, in the soft drinks all of you know that carbon dioxide is soluble under high pressure. In this case, if pressure is increased, then the solubility of carbon dioxide in the solution is also increased. In this case, there is a formula of Henry, which is known as Henry's law, the effect of pressure on solubility. According to the Henry's law, at definite temperature, the solubility of a gas in the liquid is proportional to the applied pressure. Solubility product. Solubility product. Dear students, first I would like to give you an example. Calcium carbonate. Calcium carbonate is a less soluble salt, and at the 25 degree centigrade temperature, in the aqueous solution, calcium carbonate ionizes to produce calcium ion and carbonate ion, and the multiplication of molar concentration of calcium ion and carbonate ion and the multiplication of molar concentration of calcium ion and carbonate ion is 8.7 into 10 to the power minus 9 mole square liter inverse 2. So I can give the definition. At definite temperature, the multiplication of molar concentration of ingredient ion of a less soluble salt in the saturated solution is called solubility product. So dear students, what are the conditions of solubility product? Of course, the temperature is fixed and the salt will be the less soluble salt and the solution will be the saturated solution. Then the multiplication of the molar concentration of ingredient ion of that less soluble salt is called solubility product. So the solubility product of calcium carbonate is 8.7 into 10 to the power minus 9 mole square liter inverse 2. What does it mean? It means the molar concentration of calcium ion into the molar concentration of carbonate ion in the saturated solution of calcium carbonate is 8.7 into 10 to the power minus 9 at definite temperature. So dear learners, I think all of you have understood about the solubility product. Now come to the another point, that is ionic product. Ionic product. Suppose calcium fluoride ionizes in the aqueous solution to produce calcium 2 plus ion and fluoride ion. So KIP is equal to molar concentration of calcium 2 plus ion into molar concentration of fluoride ion. In this case, the coefficient will be the power. Dear students, so what will be the definition of ionic product? At definite temperature, the multiplication of molar concentration of ingredient ions of a salt in the solution is called ionic product. So what are the major differences between the ionic product and solubility product? Dear students, just try to remember it. In case of solubility product, I have told you it will be a less soluble salt, but in case of ionic product, it can be any types of solute, any types of salt. And in case of solubility product, I have told you the solution has to be saturated solution, but in case of ionic product, the solution is, it may unsaturated or also saturated solution. And in case of ionic product, the value of KIP, I mean ionic product, is not constant, but in case of solubility product, the value of solubility product is constant in the presence of common ion effect. And dear students, I will also discuss about the common ion effect after this topic. Dear students, now I am going to discuss about the common ion effect. Here you can see two different types of solution are given. First one is lead chloride in water, and second one is lead chloride in 1 molar concentrated potassium chloride solution. And if you observe both of the solutions, you will see at 30 degrees centigrade temperature, 12 gram, if 12 gram lead chloride is dissolved in 1 liter water, then it will be the saturated solution of lead chloride. But if I take lead chloride in 1 liter of 1 molar potassium chloride solution, in that case only 0.5 gram lead chloride is dissolved. What is the reason? Actually, in case of 2-non solution, the lead chloride is actually less soluble or weak electrolytic substance. That's why the ionization process of lead chloride exists at the equilibrium, and in the ionization reaction it produces lead ion and chloride ion. And again, in the same solution, potassium chloride is a very strong solute and it is a very strong electrolytic substance in the aqueous solution. potassium chloride ionizes completely to produce potassium ion and chloride ion. And if you look at the whiteboard, you can understand that easily. In this case, in both of the cases, chloride ion is actually common ion, and due to the presence of common ion, the concentration of chloride ion is increased highly. As a result, the equilibrium of 1-nong reaction shifts to backward and lead chloride is deposited here, and actually the solubility of lead chloride is decreased. That's why I can say that in the presence of common ion, the solubility of lead chloride is decreased, and this is actually common ion effect. So what will be the definition of common ion effect? If there is a common ion in two solutes of a solution, then the solubility of a less soluble salt is decreased due to the presence of common ion. This decreasing of solubility of less soluble salt is called common ion effect. Solubility product of a substance is not influenced by common ion effect because solubility product is a constant term, but ionic product is influenced by common ion effect and it is not a constant term. Now dear students, I would like to show you the relation between solubility product and ionic product. If KIP, ionic product is equal to KSP, solubility product, then the solution is saturated solution. If KIP is greater than KSP, then PPT will obtain. It will be supersaturated solution. If KIP is less than KSP, then PPT, precipitate, will not obtain. It will be unsaturated solution. So no more today, dear students. In my next lecture, I will discuss about the identification of different positive ions and negative ions, different cations and anions. And goodbye.